In the next couple of minutes, we are honored to have all present here witness the signing of the Memorandum of Understanding between Gardens by the Bay and NUS Enterprise. It is most fitting to do this Memorandum of Understanding signing alongside this plenary session on intelligent urban mobility to demonstrate the active collaboration between entities to advance the transformation of urban mobility. May I now invite Ms. Peggy Chong, Deputy Chief Executive Officer of Gardens by the Bay, up on stage. Ms. Peggy Chong, please. It is also my pleasure to invite Mr. Sean Patrick Flanagan, Director of NUS Industry Liaison Office, to join us on stage for this signing. This Memorandum of Understanding between NUS and Gardens by the Bay is signed for the collaboration in relation to the test bedding of NUS autonomous scooters within the designated test site on the Gardens premises. This test bedding program will assist NUS in improving and enhancing the autonomous scooter prototypes, which will eventually lead to commercialization. The Gardens is keen to participate in this test bedding program with NUS to explore the benefits that it could potentially provide to enhance the visitors' experience, particularly for the elderly or disabled. The signing of this Memorandum of Understanding enables collaboration to the mutual benefits of NUS and Gardens and will be for a duration for a year. I'd like to now invite the representatives from Gardens by the Bay and NUS Enterprise for a photo opportunity. So may I invite the representatives to please come on stage and we will take a photo together. Okay, thank you very much. May we invite all our guests and representatives to please take a seat. Ladies and gentlemen, let's give a big hand to this collaboration. Thank you very much, and I wish that great opportunities will be offered by this new partnership. Thank you, Ms. Peggy Chong, Mr. Sean Patrick Flanagan, representatives from Gardens by the Bay and NUS Enterprise. Ladies and gentlemen, have a wonderful afternoon.
Hi. Good afternoon, ladies and gentlemen, and welcome to the Futurenow panel discussions. The topic for this afternoon is intelligent urban mobilities. My name is Manto. I'm the MC for these sessions. And when we thought of these topics some months ago, we think these are very important topics which require immediate discussion. And I would say this is even more topical now, given your participations. Without further ado, I want to introduce the moderators for the panel discussion, Professor William Lee. William Lee serves at the NUS Advanced Robotics Center, where he works on robotics autonomous technology with artificial intelligence concepts, architecture and development of innovative solutions from research to IP translation activities. Previously, he has worked 10 years at Panasonic Corporations as an R&D engineers, and another 30 years at HP company at Palo Alto, California as Principal of Technology Operations within the Printing and Personal Computer System Group. Williams has deep research, innovation, product development, manufacturing, procurement, supply chain operations, go-to-market, and commercialized experience. May we welcome Professor Williams on stage.
I quit my job and I want to go to my girls' week.
Good afternoon. Good afternoon. The session went a bit late, so we'll try to catch up time. I hope that the MOU is a great collaboration between Gardens by the Bay and NUS Enterprise. So why do we want to do that? Because it's about autonomous technology. How could it be part of our urban mobility solution? As you know, 4 years ago, autonomy was spun out through our lab. So the conquering of the roads has been development for the last 4 years. But now, how could we run through internal transportation? So those are the things that we will get the experts to talk about. So without further ado, let me introduce this first speaker. All right, Adjunct. So Adjunct is the Director of Development of Ecosystem at NVIDIA. So Southeast Asia assists innovators, researchers, and techno entrepreneurs to accelerate GPU adoption to their R&D and software solutions needs. He has direct experience and passionate in accelerated computing, software, research, deep learning, design, and development covering of end-to-end needs. He also published a lot of publication and patents and software within the deep learning work for the last year. So without further ado, let's get Adjunct from NVIDIA to give us the most advanced of technology, what is been unleashed and how could that inspire us to put on application for the future. Adjunct, please.
Thank you very much, Prof. William. And we work very closely with NUS, Prof. William's lab, and Prof. Marcelo. In fact, we have joint activities through our MOU with NUS School of Mechanical and Engineering. There's a lot of work being done. So thanks for Prof. Marcelo and Prof. William to work together with us. I have 15 minutes. I'm going to go fast. I'm going to cover some of the topics so that it helps us. So what we've seen, the GPUs being used for various type of applications, development purposes. It goes beyond standard applications in the PCs and games and so on. We have seen them adapted across, whether it is the hospitals, whether it's autonomous vehicles and so on. We see increased demand in the last 5 to 6 years. We can see number of developers actually increased 10-folds in the last 5 years. The downloads has gone 5-folds, and the registration the last year we had 8,500 GPU core developers join our conference developing various type of application. Now, in terms of deep learning or AI, what we observed when AlexNet was released, back early 2000, that was the earliest network. But today we see there are many networks being designed. These are the networks which actually powers and solves complex problem like AVs, which requires them to make a decision. And continuously what we see is, from NVIDIA perspective, the computation required by these autonomous vehicles to make certain type of decision, which is very critical, is mind-boggling. So we are pushing our GPU's capabilities to compute all type of data that is required to make a decisions. And the performance is extremely fast. In the last 6 months, we have gained almost 10 times better performance is one of our GPUs that we have. It's called DGX2. Now, how does it help is I'll share with you how these DGX are being used to simulate and test all possibilities of an AV that may it encounter what is on the road. Now, what we believe in NVIDIA and what we are passionate about is we believe all moving machines will be autonomous in one day. Whether it could be like what MOT here in Singapore envisioning. It could be grass cutting machine. It could be a machine which helps the person in a food court so that it can move things. It could be cars. It could be ships and so on. So everything will be autonomous. Now what we see is the next trend is beside traditional training techniques, we see simulation becoming very, very important. So beside training, we actually augmented with a simulation, and I'll be sharing with you briefly how we do different type of simulation. One is for robots. This is, for example, we take a robot, we train a closed environment. It could be within building or it could be within certain areas. We train it. So we have the entire SDK, we call Isaac as an SDK. And the robot actually being trained in a simulated environment. And other data set that you can feed in as part of the deep learning you can train before it's being deployed. Right? So this is an example how we do in-house R&D and train different type of, we provide the platforms which you in turn can use it any type of robot that you're trying to train. So it knows obstacles, it can visualize, it can, what do you call perception, right? It can perceive and then it make a right decision. It's supposed to move. For example, it's supposed to attend a meeting, right? In a specific meeting room. So it's going for a meeting, right? It's just an experiment that we did in our office in Andover building. So next, what we see is for an AV to be on the road, it's relatively a complex and challenging task. It does many functions like what human being does. So it could be perception, it could be free space detection, it could be distance detection, it could be weather-based adjustment, it could be LiDAR, and so on. So what we see is we need to train the neural network, or we need to train the system with all possibilities so that it is ready to endure the challenges it's going to face when it's released on the road. So here, what we have is a simulating environment. So we can make the objects of the environment in your control, and you're a computational scientist. You know what are the parameters. You can manipulate it. You can try. So in this case, the sun can go right to left, left to right, east to west, which is maybe natural, may not be natural, and you put all these parameters into the algorithm and validate the algorithm, will it behave as what you're looking at? So that's what we do in our lab, and we provide a simulation platform to all the OEMs who in turn can train the neural networks, the system, as what they would like to do. So there's a lot of features that comes together with it. I have only 15 minutes. And how do we do is, once that is being trained, we apply that into a real environment. So this is actually using deep learning, for example, distance detection. So we see, you need to know as an object, and then over here, it does the free space detection. So in this case, here an example, we are looking at a place that you're supposed to stop. So in actual environment, when the car actually being driven in a road, it could be in urban, or it could be highway, it could be freeway, different areas. It has to encounter different scenarios, different situations. You have to train the vehicle so that it understands and perceives correctly. So multi-senses, multi-input required because it's certainly a complex decision to make. So we have the right environment and platform that we offer to all the OEMs and also developers to make use of the environment. So there are multiple functions. It could be inward-facing camera, which detects the passenger or the driver, so that you make sure you keep them alert. It could be personalized mapping, which comes through. This is in our office, in our building. We keep testing it in our office environment of the entire drive stack that we develop. I know it's pretty exciting, but then I have only 15 minutes. I go to the next video clip, right? We'll talk more about this. So next is what we do is the simulation environment is brought into a reality. So we can see over here, the right and left, it looks photorealistic. Am I right? It's actually not real. It is simulated, right? So the software here in the center, which you can see the speed, is actually the software algorithm that a developer was developing it. And he wants to test that algorithm across different environments. He can create the environment here at the right and left of the car, which is right and left mirror of the car. And he can test it in all kind of combinations. It could be day, it could be light. He can, parameterize entire environment that you would like to test the vehicle. So this gives, from some of the companies that we work with, billions or not trillions of hours that they want to train and ensure the software stack that they have is actually ready to be deployed on the road. So if you can see in this example, there will be one vehicle, I think I missed it. So vehicle will be overtaking in this year. So when the vehicle actually overtakes, the impact of the light from the vehicle actually simulated. And how does it has an impact to the driver? How does he perceives it? And if you hear the underpass over here is actually simulated. It's not really real. So you can change the lighting from yellow to white, whatever you would like to do, and train the system so that the system is ready to be deployed in actual environment. And this is the last, just bear with me. So I'm going to show a demonstration which shared by Jensen live, but I took a video clip of it, where we are trying to have a remote person and a remote vehicle brought into a virtual reality using our holodeck from NVIDIA, and how the remote person can operate a machine, in this case car, remotely. So quick example over here, you see there is a background there, multiple cameras. It's where the car is located. This is a virtual reality where the person who's sitting in different location virtually combined himself to the actual environment in this holodeck environment, which is a car, and he operates the car.
As Jensen said, this is actually out back here.
This is my last.
And in a private area. And let's bring in Tim. So
if we can increase the
show
volume
him
a little
taking
bit.
over inside this vehicle here. And let's show that he has control over the car as well. So there's the real car out there. And so Tim, if you can turn the steering wheel a little bit,
So when
we
you
can
turn
see
the
that we've
steering wheel-
got...
Oh, come on, cut it out.
Come on, that's fun.
So this is virtual reality.
Yeah, so he engaged...
Are you guys
Location.
putting this in your head right now? There's Tim in reality, but he's inside virtual reality, controlling a car that's in reality, but it's not here. Are you guys following me? Okay.
So,
It's like 3 layers of inception right now. The mind clearly exploded.
we've engaged remote drive, you can see, so he knows he has
I
control
still
over
remember
the
when
car.
we were talking about this, creating this, the people that were explaining to, we're going to build this thing. I was like, okay, explain to me one more time.
Yeah, you can't understand until you see it, then it all makes sense.
So next he's going to drive the car.
Okay, so I think we've seen this. Let's take a look from Tim's perspective for a second here, and we can have him take off and actually drive the car. As you can see, he's blocked. There's a vehicle
So this
here
is the
that's doing some
view that he
unloading,
gets
and Tim,
in the
look down
virtual
just a little
reality
bit so we can
space.
see your perspective, and he can now operate this vehicle around this obstacle and maybe take it to a safe spot in a parking lot for us. And hopefully all. So we're doing this really slowly and safely in a cordoned off area here, and he's going to try to turn off into the parking lot. Now you can see a little bit on the left here. Tim's view is
Tim
way
is in
broader.
there, guys. There's Tim right there, the invisible man.
And Tim's view is very broad. He can see all 3.
So eventually he'll park the car. It's the video is in the YouTube. You can watch it. Thank you very much.
Thanks, Adjunct. This is tremendous. Somewhere last year, October, NUS Advanced Robotics Center has an MOU with NVIDIA for the next 3 years. So we are doing a lot of development together. We're building a resource center. So we hope that all our work with my colleague Marcelo and our team, we want to make the driverless as the key of what ARC is about. Of course, with the Gardens by the Bay, we continue to look into the Jetson Xavier to be one of those platforms that continue to drive some of our smaller autonomous vehicles. So great partnership. We look forward for the next 2 years, 2.5, lots of hype and lots of technology advancing. That's what NUS is good about. So without further ado, let me run through the next speaker. James Tan has more than 17 years of experience working for the former Infocom Development Authority, IDA, and the Government Technology Agency, GovTech. He has diverse experience and expertise in ICT systems, IoT, robotic systems. James previously led a team in IDA to collaborate with Singapore Post to successfully develop and deploy a drone for the world's first mail delivery from the mainland Singapore to Pulau Ubin. All right, in 2015, as part of GovTech's Sensors and IoT Capability Center, James and his team partner with the government agencies to pilot, deploy IoT sensors and robotics technologies on citizen-centric and smart city projects. So let's have a bit of time given to James to see how more projects to put on our country as the smart nation of the world. Thank you. James?
Hi, good afternoon. I don't have a nice video to share with you, except boring static slides. But nevertheless, my message today is about enablers. We can see that through smart intelligent system on board autonomous vehicles, a lot of things can be done, right? Self-driving vehicles, very intelligently connected. They navigate themselves. But nevertheless, we think that through some form of infrastructure, we can make it even better. Say, for example, just now, William talked about GovTech, or back then in IDA, we deployed an autonomous drone from Singapore to Pulau Ubin, delivering the mail across the sea. We realized a few things. The drone is entirely on its own, relying only on GPS. It has only onboard sensors, like a simple 40 meters 2D laser rangefinder. And that's all. It doesn't have anything to help. And we are very, very subjected to the mercy of the weather. And in fact, back in those days, the haze was reaching 200-300 psi. It couldn't see where it's going. So we thought if there's some form of infrastructure that can guide autonomous systems, that can actually aid us in developing our smart systems. So here we are, 2-3 years down the road. Within GovTech, we felt that for Smart Nation to be successful, we need to bring sensors into the city. And this can be in the form of sight, sound, motion, environmental, and the last one, location, right? So through all these sensor data, we can actually pipe it to an immense range of use cases. So here we are. We conceived the Smart Nation Sensor Platform. We wanted to bring sensors and IoT into the city using ubiquitous urban assets, like, for example, the lamppost, which I'll talk a little bit more. The communication network that is available to everyone. And then an integrated data exchange whereby all these smart systems are integrated and everybody talks to each other. In a sense, we will deal with interoperability. And the last one, analytics, where AI and machine learning plays a large part in it. So why the lamppost? In the past, we have tried to identify a street asset that we can deploy sensors easily. And we came upon the lamppost because it's, in Singapore, lampposts are very dense. We have, I think LTA says that they have about 110,000 lampposts. Then MParks has 27,000 lampposts. That does not include the HDB ones and the JTC ones. So they are high density. They are actually a nationwide infrastructure. And they actually are already there, so they are low cost. And they have power. So what can the lamppost do to aid smart urban mobility? If we put sensors on the lamppost, like, for example, guidance beacon, something like a differential GPS, you know that GPS is not super accurate because the military has tweaked it such that the accuracy has been impeded somehow. If we use some form of a differential base station on the ground, we can actually aid the autonomous system to find where it is to the centimeter accuracy. This will actually augment the sensors on board autonomous vehicle or, for example, a sidewalk robot on the left. A sidewalk robot actually has a lot of challenges as well compared to the vehicle on the road because the pavement is so small, right? And then it goes up and down, and then you have traffic lights and all this. And typically, its computational power is not as high as those that's on the vehicle. So a street infrastructure will definitely bring a lot of sense and localization capabilities to the vehicle. Also, emergency services through the deployment of all these sensors on the lampposts, they can actually interoperate with, for example, the traffic lights, the gantries, and even the robots on the road and on the sidewalk. For example, right, there's an ambulance coming, and the self-driving vehicle can give way to the ambulance because it knows from far, it knows that the ambulance is coming. The sidewalk robots knows that, oh, there's an ambulance coming. There is a chance that it might beat the traffic light, and I shall not cross the road, right? And through the communication network, right, like for example, those available for V2X, say for example DSRC, Direct Short Range Communication Network. It is a mesh network. That means a vehicle can talk to another vehicle, and then to another vehicle, then to the lamppost. So this type of ubiquitous network can actually share data across all the assets within the city. And it actually brings about a lot of use cases and possibilities. So just now I was talking about sidewalk robots using the location beacons on the lamppost. As you can see, maybe next time the car sharing scheme, which they can go autonomous, and then sidewalk robots like people like maybe Honest Bee or Red Mart, they can be delivering their goods on the sidewalk robots. So having all these localization beacons can actually help smart systems. And similarly, ERP 2.0 is also leveraging off the SRC as an underlying technology for pricing. To go beyond smart mobility, all these sensors and beacons on the lamppost can also provide other forms of social services, like for example, right, a smart walking cane, or maybe a simple children tracker beacon can be carried by the young children. We can actually find where they are, locate them to the centimeter accuracy. This actually gives us a lot of capability that we previously don't have. And not only that, the smart cane can even be a navigation guiding system for the visually impaired. And also, just last year, GovTech is actually experimenting with autonomous wheelchair, which I think NUS is also similarly looking at it. In fact, we have some form of exchange and we shared ideas. Or the autonomous wheelchair, a bike having its own sensors, if we can actually bring infrastructure to it, we can actually make it more intelligent. And perhaps with infrastructure assistance, the cost for all these vehicles can actually come down because it doesn't have to rely on its own sensor anymore. It can actually offload some of these localization requirements to the infrastructure. With this, I think I have shared some of the capabilities that the Smart Nation Sensor Platform as an enabler for the smart urban mobility effort. And later on, I think during the panel session, if you have any question we can take, please feel free to ask. And thank you. I hand over the session back to William.
Thanks, James. The last slide is something that is really to what we do. Autonomous wheelchair. We will definitely try to find a way to work with agencies and also the rest of the care agencies from healthcare and so on. See how can we bring all this autonomous technology beyond the roads, the cars, to really the internal transportation. This is what maybe on this part I would like to do a bit of official announcement is that AI Medics is actually our second startup from ARC and Smart Lab. We have started it just 2 months ago, trying to bring on autonomous technology on an off-road environment, pedestrian, high-density transport. Marcelo and I, we are co-founders of this startup. We want to find a way that all the research outcome, the millions of dollars the government has put out on universities to research, we really want to see that having an impact to society. And we have identified, which Gardens by the Bay is one of the test sites that we're going to put on autonomous four-wheel transport, personal transport. And we hope that in the future, have an opportunity to work with agencies with all the experience learned from GovTech or anybody else. See how can we bring on these hospitals, for example, instead of trying to put on 200 or 500 wheelchairs around in hospital today, you got to balance it, one on the level 1 and one on a few on the car parks and so on. 200 or 300 of them in a hospital is destroyed a lot of wheelchairs lying around. So you could imagine that, let's say we have 20 or 30 of them. Is that a good thing that all of them know how to bring along to X-ray department and know how to distribute themselves in an app and bring the patients around? You don't have to wait for somebody to really push them around. So is that something that it is? I think this is a vision that we want to work along. And as our society gets aging as we go along, it's something that we want to have, our active living, mobility, and it's really part of the discussion on this intelligent urban mobility. So the last mile is something that we see great opportunity, and with that, we will bring on to the next speaker. Chris is actually the director of the Future Division of Singapore Land Transport, Ministry of Transport, where the division is responsible for generating future mobility concepts and overseeing their implementation. Prior to this, he served in various capacities within the Singapore Public Service, including most recently as Director of Strategic and Political Military Planning at the Ministry of Defense. Chris graduated with a bachelor's degree in governance and economics and also completed a master's degree in international relationship and international law. So I hope that with his next 15 minutes of sharing, see how at the whole of nation, what are the exciting visionary that we can use the technology, use the research outcome, use what our new platform like AI Medics is to be. Our booth is right there. You can come and visit after this talk. See how can we make all this autonomous, interesting, and applicable in Singapore. Thank you, Chris.
Hi, good afternoon, everyone. So I will follow from Etiken and James and what they've presented on the technology aspects of intelligent urban mobility. And I'll cover a little bit more on, I suppose, the larger roadmap that we see when it comes to urban mobility in Singapore, the policies and things like that. Yeah. But I thought before I launch into our AV roadmap, it's useful actually to provide some context to why we are proceeding on this journey. I think not everyone here is from Singapore, so some of the challenges that we face may well be something that's less well known to you. But in terms of urban mobility, we actually face quite a number of challenges, perhaps similar to other cities around the world. But I think in our case, a lot of our challenges are a lot more acute. So for instance, if you look at the 4 challenges that I've listed down here, first really is increasing travel demand. I think that's not a surprise. For Singapore, we are a growing country. We expect our population to grow further in the years to come. Perhaps to, we're about 5.5 million people today. I expect that we could hit maybe even 7 million by 2030, thereabouts. So that will add increased pressure on our public transport network, on our road network. So is that something that is, that's something that we have to manage in the years ahead. Of course, if you think about Singapore, it's a very small country. We have very limited land. So it's also not possible to really increase our road networks to accommodate the increase in transport demand that I just mentioned. Today, roads already take up about 12% of the land area in Singapore. If you compare that to housing, you have a sense of how much land roads take up. We have about 1 million vehicles today. Again, some of you may know that we recently announced a cap on the number of vehicles in Singapore. We will keep that 1 million vehicles even in the years to come. So how will we, manage this increased demand for travel versus these constraints? Third, of course, is more diverse transport needs and wants. We have a rapidly aging population in Singapore, probably one of the fastest aging populations in Asia, if not around the world. So how do you, deal with this? With the millennials as well, they have slightly different needs and wants when it comes to transport. They prefer more demand-responsive transport, something that's perhaps a more customized experience. And finally, we face increasing manpower constraints in Singapore. Some of you may not know this, but about half of our bus drivers in Singapore are actually not from Singapore. They are foreign. The remaining half that are Singaporeans, a large number of them will actually retire in the next 10 years or so. I think at the moment, the vast majority are probably already in their mid-50s or so. So, this is a particularly acute constraint for Singapore. and as I mentioned earlier, perhaps much more so compared to other countries. So against this backdrop, and the challenges that we face, we have this vision where we want to create this car-light Singapore, where people choose to walk, cycle, and ride public and shared transport, and where urban mobility, and by that I really mean the movement of goods and people in cities, can be achieved in the most resource-efficient manner, with as little manpower as possible, with as little need for road space as possible. So where does autonomous vehicles come in with this backdrop? Really, we see it coming in 3 key areas. The first is that we see AVs as something that can help us reduce traffic congestion as well as land take. And how do we see AVs achieving this? Well, first of all, AVs, as I think some of you will know, are able to travel much more closely together compared to human-driven cars, simply because of their sensors and algorithms. And so with that, you can pack far more vehicles on the road compared to, say, human-driven vehicles today. But secondly, what we're hoping is that AVs can actually make public and shared transport that much more convenient and accessible, that people will actually choose to move away from private transport, from private ownership of cars, to taking public transport. And again, once you have that, you can also achieve this objective of reducing traffic congestion, reducing land take. Secondly, reducing reliance on manpower, I think that's not a surprise. AVs probably at least you will not need a driver in the very long term. I think in the short term, there's going to be a phasing or staging kind of thing where you still need the human in the loop, the human in the vehicle for some time. But eventually, I think with AVs, we can remove the human from the vehicle. And finally, of course, AVs can help us to increase road safety. I can't remember the exact figure of how many road traffic accidents there are today, but clearly, I think most of you would have heard about the promise of AVs, that AVs don't get tired, they don't drink, they don't get drunk, they don't get distracted, they don't have a mobile phone to check. So theoretically, at least, with AVs, you have improved road safety, and with that, you can also reduce economic losses from deaths, injuries, and other traffic accidents as well. So these are the 3 key areas that we see benefits in terms of what AVs can bring. And really, this was something that we saw, 5 years ago when we first started this journey in Singapore. When we thought about it back then, I think we saw that there was a need for a really interagency, whole-of-nation kind of push to help us bring AVs to where we want to go. So we set up this committee back in 2014. It's a private-public committee comprising both government agencies as well as organizations from the private sector. Some of the key players in Singapore working on AVs are represented on this committee. And under the aegis of this committee, we worked out this vision for AV deployment in Singapore. And for us, really, we see AVs being deployed along these 4 tracks. The first 2 tracks, I think you'll notice, are more to do with people movers, and specifically to do with shared and public transport modes. So this is perhaps a little bit different from some other countries where the focus for AVs is more, perhaps using AVs more for private transport. In some cases, maybe a one-for-one replacement for the human-driven car of today. For us, the vision is a little bit different. We want to use AVs for shared public transport. The last 2 trusts are more with the deployment of AVs for the carriage of goods, cargo, and also the use of AVs for utility operations. By that, I mean road sweeping, rubbish collection, public utility services, basically. So these are the 4 tracks that we see AVs being deployed for. So let me just very quickly bring you through, I suppose, our vision for where we see AVs in the future. This is something that we worked out again back in 2014 or so. So 4 years. I want to say a little bit dated, but it's 4 years ago. So in our vision, really, we still see a lot of room for our MRT or mass rapid transit rail network. This will still remain the backbone of our public transport system, simply because it's the most efficient and effective way of moving large numbers of people across Singapore. Each train can take up to 1,600 people. You can't beat that with buses, you can't beat that with cars. So MRT will still remain the backbone of our public transit network. And I think some of you will know that in Singapore, we've committed to doubling the length of our rail network by 2030, such that around that time, about 80% of all households in Singapore will be within a 10-minute walk of a railway station. That will bring our rail network to about as dense as, or perhaps even more dense than New York or London or Paris today. But beyond that, of course, we see AVs coming in to provide fixed and scheduled bus services, This can be for both intra-town as well as inter-town travel. For first last mile connectivity between major transport nodes and to homes or to other locations around the neighborhoods, we see smaller capacity on-demand shuttles providing that first last mile connectivity. But I mentioned earlier that we are hoping to reduce land take from roads, and the whole idea is that with the deployment of AVs, with hopefully people moving towards more public transport, we can actually reclaim road space and really use the surface space that we have for community areas, for recreational purposes, bring about a far more livable environment for Singaporeans. Some of you may have noticed that there are drones in the sky in the map in the picture here. We've worked out the AV vision and roadmap. We are in the process of working out something similar for the aerial domain as well. Some of you would have heard about passenger drones, cargo drones, and so on. So that's something that's potentially coming. I won't cover this here, but maybe the next time around, next year or something, we can share a little bit more about what you have done on that front. Of course, I think to accompany the day scene, there must always be a, there must always be a night scene. I spoke about the autonomous trucks, autonomous utility vehicles, and really our vision for how autonomous trucks and utility vehicles are deployed is that we want to deploy them during off-peak hours, perhaps even at night. Today, if you want to use trucks for carrying goods and stuff, you've got to find a truck driver that wants to drive at night if you want to do so at night. And it's not easy, you incur higher costs most likely. But with autonomous technology, there's no reason why such traffic cannot be moved from peak hours to off-peak hours, thereby enabling us to really smoothen out the traffic on our roads, leading to less traffic congestion. So this very broadly is the roadmap that we have for the deployment of AVs in Singapore. Today we are in phase 1 of the roadmap, where we are talking about really doing trials in test beds, more controlled environments, and gradually expanding them as we go along. Some of you would have been to the One North area in Singapore. It's like a business park, industrial district, where some of the AVs are already trialing, I think, for about 3 years now. The next phase is really where we see us moving to a more limited deployment of AVs, where we deploy them for operational commuter services. And finally, of course, we want to deploy AVs island-wide or country-wide eventually. Yeah. So a quick snapshot of where we are today. I spoke about the 4 tracks earlier. So you see some of the trials that are taking place today in each of these 4 tracks. In terms of fixed and scheduled services, we have been, actually some of these trials have been going on earlier than even 4 or 5 years ago. I believe this particular platform, the Navia Induct, this has been trialed, I think by NTU from about the early 2010s, 2011, 2012, something like that. The Navia came in more recently, but still a couple of years. This actually has been, it's an operational service already at Gardens by the Bay. If any of you want to take an AV, go to Gardens by the Bay. I think you pay $5. You can ride in this AV. But of course, the more exciting development for us is that we're working towards the development of larger capacity buses. So currently, we have some projects where SD Engineering and NTU are developing these 12-meter long buses, the same kind of buses that you see on roads today. And this is exciting for us because these are larger capacity buses that, to us, is the mode that we actually want to deploy. In terms of the point-to-point mobility on demand kind of platforms, in One North, we have some players already trialing their technologies there. We started with this small area in One North, where we had about 12 kilometers of public roads that the AV developers can trial their platforms. Today, we are about 70 kilometers of public roads altogether where the AV developers can test and trial their platforms, ranging from universities to residential estates. So quite a different environment, perhaps, compared to other countries where they are trialing their AVs in towns where the traffic is lighter, where there are less people. Yeah? In Sentosa as well, some of you may have read the news recently. We are also trialing our own Made in Singapore autonomous bus. And this is a picture of that Made in Singapore autonomous bus. So if you're in Sentosa as well, keep a lookout for this bus. It's undergoing trials right now, and sometime next year we hope for the bus to do public trials with passengers. Right. In terms of the other 2 tracks, slightly further behind in terms of technology development, I think, compared to the first 2 tracks. we have been undertaking a trial with, between MOT and PSA for an autonomous truck platooning concept. And that's something that we are testing right now. And between MOT and NEA as well, we currently have a partnership where we're hoping to develop autonomous road sweepers and autonomous rubbish collection trucks. Right. So, what you saw earlier is really what we are doing in terms of phase 1. And already, because I think the technology is progressing quite well, and we're quite confident about where it's going, we're already starting to look ahead and think about phase 2 of our roadmap. And some of you will know that we announced last year that we hope to deploy autonomous buses and shuttles in 3 of our towns in Singapore. And that's really sort of the start of the phase 2 of our roadmap. I'll cover a little bit more of that in the next few slides. So, yeah, these are 2 areas in Singapore broadly where we're hoping to deploy AVs by 2022. Punggol is to the northeast of Singapore. I have a map to show you where that is later. But for the non-Singaporeans here, it's a residential town. Most of it is already quite built up today, but we're developing further parts of it, and there will be a new university there, a Punggol Digital District there as well. Tengah and JID are 2 contiguous areas to the in the western part of Singapore. Tengah will be a HDB new town, a housing estate, 100,000 people. The Jurong Innovation District will be more of a business industrial park, again about another 100,000 people or so. If you go there today, there's nothing there, it's forest, but by 2022, the first phases should be ready, and we want to deploy AVs to provide first last mile connectivity in these 2 areas. Yeah, so very quickly, these are where the 2 areas are. Punggol is here, JID and Tengah is broadly here. Yeah. And what we are hoping to do is to deploy AVs for 2 public transport modes. The first is, as I mentioned, autonomous buses. These are your 12-meter typical public buses carrying about 80 to 120 people. And we also want to provide autonomous shuttles that can give that shared on-demand kind of service. This will be a new form of public transport for Singapore, actually. We don't have something like this today, but we think that this concept can be potentially game-changing in terms of, really increasing that convenience and accessibility of public transport. And we're hoping for the buses and shuttles to be SAE level 4, level 5. We're not talking about segregated lanes here. We're talking about them fully able to traverse in mixed traffic. And just one last slide. I spoke about the vision, but it's not something that happens overnight. It's a very long and arduous journey. And in particular, there are a lot of things that we have to work on. Things like infrastructure and systems, regulations and standards, public acceptability, so on and so forth, to really build that ecosystem to enable us to deliver the vision that we want. I think I'll stop here because I'm mindful that I'm running out of time, but I can share a bit more about some of these areas if there's interest. Yeah? Thank you.
Thanks, Chris. With that, let's get back to James and Adjunct. We will have the next 15 minutes, I think just right, 15 minutes before our time's up, for a dialogue session panel that we can chat about. Maybe allow me to go back the slides. I like the slides about the vision. Is it moving? Or? Back. Can we go, is there any way we go back a few slides? Is it here? Is it? Sorry. Yeah, go back to that vision, that city thing. Maybe put as a backdrop for our discussion. Yes, sorry. One more, yes, this. Probably, come, James, take a sit. So it's also a good privilege that the NUS Advanced Robotics Center is part of the consortium to do the full-size autonomous bus, and that is being awarded by LTA. So thank you for that. That is a 42-month project. We're supposed to deliver by end of 2020. My guys are working so hard, they're not here, but really want to live out the vision that Singapore will be among the first countries. In fact, it will be the first country to really run on AV trials. So there will be questions running through. I think there will be a slide on Silo. I don't know where you guys got the apps to put on post questions. If not, we can run through the mics to to have questions on the fly. It's really the next 15 minutes of what we want to talk about, intelligent urban mobility. What can we bring on the vision? What a technology can unleash to help us? And what the deployment test bidding that we can run through. So, okay.
Wanted to ask, since the deployment of the AVs are still in phases, when you mentioned on the last slide, on the last phase is all tracks, are you saying that the AVs will run on designated tracks, or this is going to run all over the place, and there's all the LiDAR and all that to guide them? Otherwise, then they will mix with human drivers, and there may be some concerns, you know? Is it going to be a special bus, like bus lane? It shares the bus lane with the buses?
So the way we see AVs being deployed in Singapore, unlike perhaps other countries, we see AVs being deployed in mixed traffic. We won't have segregated lanes for them. We expect them to be able to interact with normal human-driven traffic. But of course, in Singapore, we do have something called bus lanes, and the expectation is that because these are public transport, they will be able to access these bus lanes, which hopefully can make the introduction of AVs a little bit easier. But I think capability-wise, our hope is that these AVs can navigate in fully mixed traffic, just like any other human driver. That is the long-term goal, that they should be able to navigate traffic just like any other human driver.
Just to add on, in terms of this generally what we see is there is multiple levels. So level 1 to level 5. So level 5 capability is you don't have a human driver. It means you don't have a steering wheel. So the AV could move by itself. And the intention to have that particular AV should be able to run in a mixed mode environment where there are multiple vehicles with human and without human as a driver. That's the intention in terms of technology perspective. So we are working towards that to be done. In some, we already have success.
Maybe I'd like to probably just link up is that since we are started up AI Medics as the pedestrian pathway for elderly seniors, really taking the pedestrian walkways. Maybe I would like to invite James to give a bit of comment on the AVs and on the autonomous scooters and all this stuff, wheelchairs. How would his infrastructure help to really make the whole thing kind of connected? Is that something that James can comment on that?
Okay, I was about to augment the other answers. I want to share an experience that we have at Changi Hospital. So I'll come to your question later. So the interesting thing is that the scenario was we deploy 2 autonomous wheelchairs at the taxi stand. So when the people arrive and they ask where is specialist clinic D, for example, and then the chair is supposed to bring them to the clinic itself, right? The journey is only 200 meters. Because the chair is designed to give way to human beings, of course it will try to navigate and try to avoid obstacles and all this. But there's a lot of human beings walking around and other wheelchairs. The chair took 9 minutes just to complete that 200 meters journey. And it keeps repeating by itself. And then we realized that that algorithm is not going to work, because if you keep giving way to the human beings, the chair might or might not reach the destination within acceptable time frame. So having said that, so now back to William's question, right? So when we mix self-driving systems, fully autonomous system with manually piloted vehicles, there's actually a lot of consideration. And we need to know who moves first, who has the right of way, what are the rules of engagement. For a human being, I think the highway code, that might be a need to change a little bit to be aware that actually there are self-driving systems now. If there is an autonomous emergency vehicle, who has a right of way, for example. If there's a wheelchair at the zebra crossing, who has a right of way. Is it the ambulance or is it the autonomous wheelchair? Previously, I think we leave it to the judgment of a human being. But now if we have an elderly on an autonomous wheelchair with an autonomous ambulance coming, trying to contest for the same junction, I think there's some food for thoughts before we actually deploy that system. To resolve it, the first thing that we need to do is we need to enable the communication between the two entities. And then the system will make a decision like who will go first. Previously, we rely on the body language between human being, right? You see the car looking forward, you know the vehicle is trying to move, right? And still you have accidents. But for vehicles, they can't tell your body language. So some form of interoperable communication standards must be established before all these entities can be pulled together and they work together. It doesn't matter whether you are a go-kart or whether you are a big 12-meter bus. Yeah, that's my take. Yeah.
Thanks, James. I think Chris want to add on that.
Actually, just following on that point, so this is something that I think we're quite keenly aware of, and currently actually the international conversation when it comes to things like standards, codes of guidelines, that kind of stuff, is not quite mature. So what we're currently doing in Singapore is actually to establish our own standards when it comes to autonomous vehicles. So we have a standards development effort right now where there are 4 working groups. One of them actually is on the highway code for autonomous vehicles. So that's one aspect of work that we are looking at. How should AVs behave on the roads in their interactions with other human-driven vehicles, in their interaction with other connected vehicles as well. But beyond that, of course, when you talk about standards, there are other things like functional safety standards, cybersecurity standards, data management standards, and it's a process that's ongoing right now. We want to deploy, develop all these standards and deploy them eventually, so the industry can also, come in to deploy vehicles more easily.
Adjunct, your take on this?
Yeah. So what industry sees is we see the main pain points of AV, or at least vehicles that we have today, where it is a human-driven, where exactly biggest pain point, and the industry trying to solve the biggest pain point, and it actually grow stage by stage. For example, if you get stuck in traffic jam, and you spend 1 hour and so during heavy downpour in Singapore. So if you were to drive by yourself, they get tired, they get agitated, there is a possibility for accidents much more higher. So if AV comes in that kind of environment, it actually can assist the human being to drive in a congested or when there is a heavy traffic. So we see such kind of features being included in the AV in an incremental manner based on the stages, whether level 1, level 2, level 3, all the way to level 5. So we see a pain point based features are being included. So in this case, for example, give an example of wheelchair autonomous. It's a different type of pain point that you're looking at, right? So each of them are going to have different type of implementation techniques. And of course, we need regulators to come and regulate it and get it adapted. But the approach is, again, what I said is pain point specific. And that is kind of definitely we see incrementally being adapted and getting into operation quality like implementations today.
So our autonomous mobility device, which we're going to commercialize, it's really looking at all these issues. All right? If you take 9 minutes or 200 meters to go through, this is where we really want to tap upon all the technology. Right? The technology to how could we use AI to train it, to learn how a typical human would to navigate in a crowded environment. So I guess if all of us will go through some Chinatown, New Year, some Pasar Malam or something of that, we will kind of move in a sense that we find every time somebody gives 2 inches, we take 3 inches from them. So I guess it's something that we will have to find ways of technology, either give a small little beep, try to kind of bumper to bumper, but not giving that intimidating crashing into it. I think that's where technology has given the opportunity. AI able to learn how you train it. Hopefully that device will take the bit of, I won't say risk-taking, it's how we take opportunity to move forward. I look forward to that enabling from the technology developers. That said, there'll always be some guys trying to turn around and say, why are you bumping to me? That's where we need the 2 guys here on record 3. How can we mitigate the standard? But it is just tremendous looking at the slide. One day, it will be not too far away that we have all these things running on the basement, running through the night, and the pavements are all autonomous, shared mobility. I really want to tell our folks at MOT is that littering bikes everywhere is no longer an issue then, because all autonomous devices will go back its own home somehow. So that is really the vision of it. We will probably have the next 3 minutes for probably the last 1 or 2 questions from the floor before we close the session. Can we have that before we have that? Thank you.
Because this topic is about AV, right? So including flying passenger AVs. I just want to know, what I know the roadmap for that is not out yet, but what is the current view of where and when such flying AVs are possible, and in Singapore's context, what is the use case for it, and what is the in terms of the constraints or because of the safety and airspace and privacy and such issues. Thanks.
Now we start with Chris. I really want James, because he has experience in trying to send posts to Pulau Ubin, so that he talk about how that. So maybe Chris first.
Yeah. So maybe I just start with the last question on constraints. So as some of you will know, Singapore has very dense airspace. We are a very small country. The airspace actually is literally filled with planes and aircraft. So there are some challenges in terms of deploying drones on a mass scale at this time. Currently, under the International Civil Aviation Organization rules, I think there has to be a certain amount of separation between traditional manned aviation as well as drones. But I think the vision that everybody is working towards is that eventually, when you have something called the US traffic management system that can interface with your traditional air traffic management systems, technology will allow us to bring these two types of aircraft much closer together. They can then enjoy and share the same airspace in a much more dense way than we can today. So that is the end vision, where you see thousands of drones perhaps coexisting with traditional manned aviation, or potentially even unmanned but larger passenger aircraft. That's in the long term. So as we work towards this, I think it's going to be a very gradual, staged kind of process. If you talk to some of the major drone developers today, the passenger drone developers, a lot of them are giving about 2025 more or less for the introduction of piloted drones. These are large eVTOL kind of drones with about 4 to 5 passenger capacity. So that is the initial stage, where you have piloted drones flying no different from, say, helicopters of today. But of course, the difference is that these drones will likely be much cheaper and much safer because they're electric and they are VTOL. So they're also likely to be less noisy. And with that, they're able to do, I suppose, much more frequent runs. In a sense, think of like the bus services of today, right? If you have a drone landing, taking off every 2 minutes, even if you're talking about a 5-seater capacity, perhaps that could make a little bit of difference. But I'll stop here and let, I think, my colleagues jump in as well.
James, when can I have my next pizza? Instead of Pulau Ubin.
To be honest, that flight from Singapore to Pulau Ubin could not have happened without RSAF, without CAS, without MPA, without SPF supporting us. The airspace was closed. The runway at Paya Lebar was closed. The shipping lane has to be cleared before the drone can fly. That was a technology proofing event, not a real trial. So what I'm trying to say is that in order for that flight to happen, a lot of things has been done before that one drone made one trip. Actually, we did it twice. We flew it, and the first time when we crossed it, the GoPro camera didn't capture the historical event. We called back to CAS and MPA, say, can we do a rerun? They said, what? Like, all right, never mind, let's do it again. And we did it again. So the point is, to make it happen as of now, I think everybody's working towards it. It's not there yet, but I think MOT is leading a whole team of government agencies to work towards it. If you were to ask me when, I don't know. That depends on how technology progress. But as of now, I think most likely you will not see something in 6 months.
So the challenge is actually with autonomous BVLOS, or beyond visual line of sight operations for drones. And that really is the technology challenge right now. I think the technology is there if you're talking about the military spec drones, but these are going to cost millions of dollars. So, and the issue is also with squeezing them onto a small enough drone for commercial purposes. So cheap enough and small enough to be deployed for commercial operations. I think that is a technology challenge that we'll need to work at maybe for the next 5 or 10 years maybe.
Okay, thanks for the comment. On that, I have to thank Adjunct, Chris, James for putting time together, and all of the great audience that supported us for the last an hour or so. And we will close this session for next to come along. But that's it. Before we really end, I really want to put a quick question. I need my pizza on a drone off my window. So something for you to think about and cheer about it. So support our booth. AIMatics is out there. Look at our autonomous scooter out there. It will be our device in any way, somehow. Bike sharing will be a thing of the past. My guarantee to our good friends here. NUS Research Advanced Robotics Center, and on behalf of my team, Prof. Marcelo is not around, my colleague. We are working hard to make AV happening, and that's where we are. Thank you very much.